and welcome to another one. Um, Today we're going to be looking at offline samples optimized. So um, the optimized solution to what we had. And one might be asking the question, probably before I get into it, what's the difference between online and offline sample data? And that's basically just as I explained yesterday. It's like streaming, right? So online is like streaming. So you basically the data is coming in on the spot, right? Whereas offline you already have your data pack with you, so you iterate over a fully, actualized data set. But online you're taking it into account that this data is just coming in, right? And you want to make sure that what you have or there is a probability equality, right? Or there's a fairness to the amount of or to the packets that you get to keep. Basically, that's just the difference. One is it's like streaming in concurrently or at the time, while one is uh, coming in late. So basically, or coming in, or you already have one in hand. Basically, that's the variation. And now let's get into it. Looking at the fact that we have the full application, looking at the fact that we have the full application, how do we handle it, right? So that's the question. So what do we do? So it's a very short one. It basically says uh, the offline sample is to optimize is here, and it says array list sample size initialize. Sorry, integer rather. The type in array is a type of list. Obviously, it's coming in as a list, so we have the full sample size, and then the sample size is just an integer. So we are going to be saying, oh, this sample size is what we want to have in our storage. So basically, having that, now we're going to iterate over every index, right? So for a current index, that would be 0 for the initial f point within the range of the sample size. So we're going to be just doing this for the sample size we have. So we're going to be iterating over it just for the sample size we have, just to select a few of them. So we say random index. So we go through the stuff and we pick out a random index, right? So when we pick out a random index from the current index to the end of the or to the end of the sample size we have. So let's say from 0 to if we have maybe 5, or maybe for this example we have here, we have 5, right? So we have to go and get the correct the sample size from there. So we do a random integer. So we get a random index, say maybe we get 3, right? Then we go to the next line where we see what array current index, array random index. And then what do we do? Basically what we are trying to do is that we are picking the array at that current index, right? So at the index of 0, and then we are replacing it at the random index that we found. So what does that mean? That means we have the full set, and that we are trying to place on our first index the index that we are going to export. So basically the index that we are going to leave within you know our network's size, or basically storage size. So basically that's what we're trying to do there. So we switch it around. The current index, which is the one at 0, and the random index, which is the one that probability fell on, and it gets to be within the mix, and then we get that. So we do that 3 times, which is the number of times we have the samples. The number of times we have or the size of our storage, and then we do that recursion. Now, what is brilliant is that after the first one goes off, right, after the index of 0 is done, the recursion, or like the for loop, or the iteration, right, basically takes it to the next one. So after we are done with 0, we don't have to worry about 0 anymore. We now move to the next guy. So basically, it's handling that for us, making sure that we are moving along while picking out variables at a randomly basically. So and then at the end we now call the array because we know we are making use of the same array that we came in with. So we were given a packet of five, an array of 5 values over here, and we made use of this same array that came into the function to call the return on it. So we say array sample size from the beginning down to that sample size, because by this time we have picked 3 random numbers. If 3 is our this thing, just as you see here, we've picked 3 random numbers to to represent or see your normal or however you want to say it, and basically that is it. So we see that this is an O of n because obviously it grows as the number of array grows because we are iterating over every single one of them. But the O of n is one because it has no affiliations with, doesn't grow as the stuff grows, because now we are calling directly um, we are using directly the sample size or the array that we are calling. So we are not basically, there's nothing growing with any the space is not growing as the maybe sample size increasing. So we have an O of one, the which is the advantage of this guy, as and even more of an advantage because in the other one we made use of, we had an O of nk, I think. Yeah, we had an O of nk. Is this it? Is the online sample? So it's the offline sample brute force. So yeah, of NK, because here we made use of, we iterated through the entire stuff, but we also made use of I think we also made use of a cutting or something of the sort. Let me see why we have of NK. So basically it's the depth.
2,000 years later.
Okay, so because of our recursion loop, right? So because of our recursion and backtracking, right? So we are going into deep. We are going to go through every of them, but we are going to still backtrack to a certain depth. So basically, that is why we have O of nk, because even after going through every one within the range, right? We are going to still call back, make backtrack, and still iterate again. So then that depth that we are going into is why we have O of n of k, basically. Muchas gracias. See you on the next one. Guten Tag. Auf Wiedersehen.